The even root function is another function that we need to be able to recognize how the function looks and then know what to do to find the domain. An even root is any kind of root that's an even index. If there is not an index written, it's understood to be a 2. If it's some other index, the index must be shown. So in this particular example, there was no index shown within the root symbol, and so it's understood to be a 2, which would make it an even root. We cannot take even roots of negative numbers, which means that whatever value is underneath the root must be a positive number. Mathematically, to do this, we set whatever is underneath the root greater than or equal to 0, indicating that it could be either 0 or anything larger. Later, we will specifically learn how to solve these type of inequalities, but I will at this point remind you of things that you've learned in prior classes that would help you solve this inequality. We would first want to subtract over 5. The 5's would cancel. We'd be left with negative x is greater than or equal negative 5. There's an understood negative 1 in front of the x. We want to divide out the negative 1. If you have an inequality and you divide by a negative number, the inequality symbol must switch. This is the only time that you will switch the inequality symbol. Only when you divide by a negative number. So in this case, dividing, we will end up with x is less than or equal. Negative divided by negative is positive. So the domain for this particular function is any number 5 or less. If we were to draw a picture of this, we would be saying that 5 could be included, but it's got to be less than 5. So the domain is equal negative infinity to 5, but you can include the 5 in your domain. Okay, this would be the only work that you need to show me, but to see it on the calculator, you go to the y equals menu. Any kind of function you have in there, just clear out. The root button is right above the x squared. So to access that, you're going to do second square root 5 minus x. I'm going to graph this in a standard window. And there is my root function. So we can see that the graph looks something like this. It ends at this value. That value, if we were to look and see, is at 5. So the graph starts at 5 and goes to negative infinity on the left, and so we see why that justifies our domain.